Welcome to our channel. Here we are going to look at an earlier problem, that is letter combinations of a phone number. So in this video, our plan will be the following. First, write by explicit construction, right? And in some sense, this is the brute force. And then I'm going to write another solution format, which is recursive DFS. So you can also call it backtracking here. So our comment is that sometimes actually brute force solution is very important, right? So basically, if you can write brute force solution, so it's actually demonstrates your ability, right? And also sometimes brute force solution helps digestion. So I'm going to use this example to use this problem to do an example, right? So here we are given a string containing digits from 2 to 9. That's the overall 8 digits. So we want to return all possible letter combinations that the numbers could represent. So we want to we can return the answer in any order. So this is greatly relaxed the problem, right? So here is a mapping, right? That's 2 maps to ABC, right? 3 maps to DF, and so on. So here, the digit length is bounded above by 4. In other words, this problem is a small size problem because each letter is mapped to at most 4 characters. So overall, so the number result is bounded above by 4 to the power of 4. That is 16 times 16, right? So here, if you look at example 2, this is very special because this is the edge case. Now, example 3, so you have 2. So 2 can be A, B, C. So this is the 3. And then we can start from 3 and look at example 1, right? So this another 3. So 3 can be corresponding to DEF, right? So we use DEF to append to each of these 3 possibilities. Overall, we will have 9 possibilities. So this is exactly example 1. So as such, for the first solution, I'm going to write in this way. So first, I'm going to treat edge case, if not digits. In other words, we are given an empty string like in example 2. I'm going to return an empty list. So next, it will be the digits will not be null. So here I'm going to start with this. So originally we have an empty string, right? Then I'm going to make a dictionary, right? So here 2 maps to say ABC, right? And 3 maps to DEF, and the 4 maps to GHI, and the 5 maps to GKL, and the 6 maps to MNO, and the 7 maps to say PQRS, 8 maps to TUV, and 9 maps to WXYZ. I should have written this down before the video. Yeah, we have this one. Now, how do we do this? So we just iterate, right? Like from example 2 to example 3, then to example 1, right? So what we do for D in digits, I'm going to do is I'm going to add the element in the current result state, and then I'm going to add the temp element. The temp element is the for element in the result. So the previous round, right? Then for temp element in the list, we just need to dict the digit, right? dict D, right? This after this, I'm going to update the result to be this one, and then afterwards, after we iterate, so you will get the just return the final, right? So let's run it first. Digits. Let's see. Digits. Digits here. Yeah, it passes the 3 cases. Let me first do some prints, right? So for first, let me add some I, right? Enumerate. So I'm going to print I, and also the character, right? D, and the result previous result state. So that will be result equals. Then I'm going to copy this line, and then after update, line round of updates. So now let's right. So originally, if you look at index I, you look at 2. So previous state will be empty, right? But then you append the possibilities, that is A, B, C, to the empty. You get A, B, and C. So now if you look at ID equals 1, that is 3, right? Then the previous state is this, right? And then now you have 3 corresponds to D, F. So D you can add to ABC. You get AD, BD, and CD. And E you can add to ABC. You get AE, BE, and CE. And F you can add to each of those. You get AF, BF, and CF. So this is the result, right? So this will be our version we want. Actually, I like this version very much, because if you can do something in a brute force way, it helps you digest this one. So now let me write another solution. Let me copy the class signature and method. So I'm going to put it here. So I'm going to call this one version v1. So in some sense, this is a revisit, because I guess previously I should have already solved this problem. So here I'm going to copy this one. And then what we do, so I'm going to have a result. This is the list. It's going to hold all the possible elements in the final return. So solution, so empty, is used to construct the each individual elements in the final result. So now I'm going to write a function to construct this one. So start from index 0, like in here, right? And then we are going to build all those things from the digits. So you can choose to include this one in the function signature, or you can just ignore that because it's in here, right? But now let me put it here. So first, a bounding condition or stop condition, if this I equals the length of digits. Corresponding to here, you have in the print, you have I equals 0, 1. If your I is 2, so you're going to stop. So once you have length 2, right, it corresponds to the solution list should be length the same as digit. So what we do? So I'm going to result append. So here I'm going to join the element in solution and return. Notice that I'm not going to return a copy of the system, because here I'm going to make a new instance of string, right? So you will know why we should use we emphasize this point, because sometimes this guy as a list is mutable, but we need to change its state when we do backtracking. So here, let me backtracking. So now let's look at the backtracking step. So basically, for character in dict, so digits I, right? So we are going to try to add the current character to the solution, and then continue next index, and then we can try all the possibilities. So this will be pattern will be solution append this character, and then after you append this character, you do the same thing for I plus 1 still digits, right? And then after you try this character, you go back, right? Solution pop, right? That's why I said emphasize here, because I'm not append a copy of this guy. I'm rather consider a new object, actually a different object, because this is the string. This is the list of strings, right? String is immutable and list is mutable. So as we have this, so that's done. So now let's look at the logic. Still, first we can, if not digit, so I'm going to return an empty one, right? So otherwise, if digits is not empty, so I'm going to call this one, building from the beginning and then digits. This function, you can understand it as a worker. Its purpose is to construct each individual element in the final result and then append those result elements into the result variable. After this, call this function, this result state will be modified. And then what we are going to do, we are going to return the current state of the result. So now let's run it. Name dit. So let's see, line 42. Let me dict. Yeah, it passes the 3 cases. Now let's look at the generic case. Yeah, it passes all the generic cases. So with that said, I guess that's basically about it for the coding part. Let me come back to the beginning and emphasize one thing. So here we write 2 formats of solutions. Both essentially are constructing all the elements by the coding. So personally, I like the brute force solution in this problem, because sometimes writing a solution using brute force might be harder than writing with some advanced method. If you practice more, you might also have this feeling. With that said, I guess that's it for the current practice. Thank you for watching.